Hello, and this is the Mönch cluster webinar regarding the usage of the queues and priorities and fair share. Thank you. The agenda for this presentation is that we are going to address the fair share setup, the new setup that we have implemented on Mönch, how you can tell, what you can tell about running jobs, requesting resources and useful parameters, examining the queue, getting a concise view of the queue, understanding the priority of these jobs that you are running, and then afterwards observing the usage of your group and yourself and the other users and your shares and remaining shares to determine how you're using it and how it will be used in the future, as well as some other useful tools. To begin with, the fair share setup on Mönch has been changed quite a bit, and I will discuss what fair share really means. Each of the groups that exist on Mönch from P501 through P504 have a fair share value that corresponds to the amount of funds that have been contributed by that group. This is referred to as an account. You can think of it as a bank account from which you withdraw your shares. When resources are used, Slurm charges from this bank account for fair sharing from your account as well as the group that you belong to. Previously, the P50 whatever group a user belonged to was their account and their shares were pulled only from that group's shares. Now, because heavy usage from one user can affect the entire group, we have decided to change the priorities and the shares to push those down into the groups further down. Now each user has their own account, their own bank account, which exists as a child of their group. So fair share is now charged against this user's personal account. This serves to prioritize queued jobs so that these jobs charging accounts that are underserviced are scheduled first, as such heavy users will not negatively affect other users within the same group, as was the case before. So essentially we've moved from a FIFO queue which within each group to now a fair share within each group. Overall shares for the parent groups are still respected so that each group will still get their promised shares. This was the previous setup as I discussed earlier. Each group had their own shares, and if somebody was monopolizing this share, then the other users within that group were negatively affected. This did not affect everybody because they did not see this behavior. We've changed this now to push the shares from here, from the group level, down to the user level. So now each user has a fair share distribution of their priorities. Now some details about how to run the jobs and what you should do really to ensure that your jobs will run quickly as possible for yourself. I would like to discuss the idea of using time limits so that you can take advantage of a function that we've set up called Backfill. And if there is no time limit for a job defined, then Backfill does not work the way that it should. I'll describe what Backfill is in the next slide. Here's an illustration. So you have two nodes, and at this time, you have jobs running that are ready to go and are scheduled to end. This job here is scheduled to end now, where this job here will continue running. And then if there's another job scheduled to start on these nodes, there's a hole here. And what Backfill does is it allows the users to have their jobs put into these holes if the system can realize that their jobs will fit there. What this does is allow for more flexible scheduling and allows people to take advantage of holes in the timescales. So how does one do this? You have to define a time in your job. If you do not define this time, then the scheduler will assume that your job will run as long as the time limit for that queue. So what this means is if you know that your job can run within, say, 2 hours, set the time in your batch submission or srun commands so that the scheduler will be aware of the time that your job can run and then insert you into the proper spot so that you will run faster. Also, there is the concept of node exclusivity. And what this means is that a user can request to have the entire node to himself. This is useful if you're running codes that don't play well with other codes on the same system. This can affect memory access time, and the load of the system will affect your jobs if they require this sort of resource. By default, when requesting the n number of nodes for your job, the allocated nodes are marked to be only used for your job. So this means that other people or even yourself cannot run on this node. If you are not using all the cores and you don't need for there to be no other jobs, then set the flag shared to OK. This will likely result in the job launching much more quickly than waiting for the entire node to become idle. And therefore, other people can also run on this node and make use of this resource. Next, many of you have been wondering how you can read the queues and understand what is happening. So, if you're interested only in pending jobs, which most people are because they want to know when their jobs will run, you would issue a simple command such as this sq-t pd, which stands for pending. Or if you only want to see jobs that belong to your user, then you could add the flag -u and then your username or the username of the user who you are trying to read. Then, another nice functionality that my coworker George has found out by reading the man pages is to sort the pending jobs or even all jobs by their priority. And this is how we can quickly determine what jobs are going to be running next, what their priority is, what their fair share is, and who is taking up the resources at the moment and who will be taking them up. You can customize your sq command with an environment variable called sq_format. And this is a very useful thing if you like to get away from the defaults that Slurm provides you. So you're able to set the width of each column so that it's wide enough to hold the names of the fields and the entries in the fields. So our partitions are longer than the default of eight characters. So you can possibly increase that. You can also increase the size of any field so that it's more relevant for what you're trying to see. And you can also reveal different sources of information using these field denominators. The way that you can define it is, if you'll notice here, you have the job ID, which is represented by a lowercase I, the number of fields that you want within that field definition, and the percent helps you define how big it should be. And you'll see user is represented by a lowercase u, and that has 12 fields in it in this definition. And then here you can see a dot, which means that the information is right justified. Yes, it's right justified. So if you put the dot, then it will make sure that all the information is right justified, and therefore the entire length of the field can be read. And if you want to know more, you can always read the man page by typing man sq. The nice things to know here for you would be capital Q or lowercase r, which will show you, as you see here, the priority of your jobs, and r, why it's not running. Well, in this case, it's resources. So we'd like you to be aware that observing the output of SQ is somewhat difficult because there are usually a very large number of jobs that can give you a false sense of how the system is actually running. It could be that some users will submit 1,000 jobs that are single node, single core jobs. And a lot of times these single core jobs will run on a single node. So you'll have many of these small jobs running on a single node. And it's helpful if you wish to really just know about your jobs to use these different flags that we've told you. Likewise, there could be a single job that requires a large number of jobs. And this would cause a situation where you'll notice that there's a large number of idle nodes available, and you're wondering why your job is not running. And by using the SQ command that we've shown you, you can see what other jobs are waiting for these resources. So if there's a very large job that's coming, it will be freeing up the system to allow this large job to run. And as I discussed before, we have the idea of backfill implemented so that if you want to fit your job in on these nodes that are now idle waiting for this big job, and you know that they can run in a short enough time, they'll get run sooner. And here is another command that is very useful for helping understand why your jobs are not running, or why they might be pending, or what the future for your jobs might be. It is called the sprio command, the slurm priority command. And you can run this command, as is seen here, to just get a basic idea of your queued jobs that are waiting. And you can see your fair share, what is left of your fair share after your usage, and then the priority that will be assigned to you once the job is submitted. And then another nice thing is you can then see how Slurm actually takes your calculations and creates the priority for these jobs. And that is by showing you the normalized values. All of the priorities are normalized to between 0 and 1. So to view the usage over pretty much all of time, sreport is another nice command that can give you an easy way to perform queries against the accounting database. And these include but are not limited to account utilization by users, user utilization by account, cluster utilization in general, job sizes by account, and user top usage. These two commands are somewhat confusing as they basically seem to be the same thing but just backwards. So for example, to view the top users within a group for today, as I said before, it can be pretty much all time that this system's been running, which is basically since October of last year. And this is a much better way to examine resource usage than just looking at SQ. So using sreport, you can say sreport the full cluster, account utilization by user, and then the start date that you wish. So this would be March 6th, and the end date that you wish would be March 7th. And then your account, or whichever account you're trying to examine, tree, which I assume is just a way of formatting.
It's the indentation you see.
The indentation that you would see here beneath the group name. And then you can also have it just give you a percent rather than the actual CPU hours used. If you don't use percent, then it returns CPU hours. And here you can see at this point, this day, Mönch has been used by P501 58% of the time. The resources were used 58%. And then you see the amount of resources used by each user. And this will also help explain to you why your priority is set to what it is and why your fair share is at what it is existing at the moment. Now, another subject, as you may be aware by now, is that we have regular maintenance days. This is a regular thing done for the entire center so that we can address intrusive problems. So if there's a lot of nodes that need to be replaced or infrastructure that is critical to the entire center that needs to be worked on, then we will schedule this day for the first Wednesday of each month. This is often entailing things such as the global file system, the network, so all of our hardware that needs to be updated in sync, and then software updates mainly to Mönch itself. Any work that affects critical infrastructure at all of CSCS would then make it necessary for Mönch to be taken down during this maintenance day. It's usually from the hours of 8 a.m. to 5 p.m., during which time your jobs cannot run. Normally, you can submit jobs, but they will just queue. And then once we are done, queued jobs will start running and after we cancel the reservation. Something to be aware of if you're worried that your jobs aren't running and you don't know why is to do what is the command which is called scontrol show res, and this will print out any reservations that have been made on the system. This will allow you to understand why the system may not be scheduling your jobs. As the start time of this reservation that we will set every month approaches, you'll notice that less and less jobs are being used, or less and less nodes are being used, and that the idle nodes will stay this way until the end of the maintenance day.